Problems involving Pythagoras. Example 1. How on earth do we find the length of side S? Well, the first thing that I'm going to do is to forget about the larger triangle and work with the smaller triangle, which is to say the triangle which has sides 3 and 7. I'll just draw it here. This 2 is a right angled triangle. That side is 3 and this side is 7. That might be useful if we worked out the length of this side here. Now it's a shorter side calculation, so we're going to involve a negative. X squared equals 7 squared minus 3 squared. 49 minus 9, which is 40. And remembering to take the square root, x equals the square root of 40. Now I could work that out as a decimal. I'm just going to leave that at the moment. There's a reason for that. What I'm going to do now is to look at the largest triangle. There are in fact three triangles in the diagram. I don't know whether you can spot all 3 triangles. The triangle that I want to work with now is the largest of all, and I'll draw it. Here's the right angle. Here is the side S that we're trying to calculate. Now we have just in our calculation to show that this side here is the square root of 40. That leaves one side to calculate, this side here. Now we can see from the diagram 3 plus 3 is 6. So we can go ahead and work out the value of S. S squared, now it's the longest side calculation. We're trying to calculate the length of the hypotenuse, so there'll be a positive sign. It's 6 squared plus, now if I write it as a root 40 squared, I hope that won't cause any confusion. It probably will, but we'll see what happens. 6 squared is 36. And square root of 40 all squared, well, it's just this answer here. 40. And that's 76. And if we take the square root, we get the answer 8.72. This second example is a bit more difficult than the first one. What I'm going to do, there are 3 triangles in this diagram and I want to work out the length of side C. Well, we can only work out one of the sides of the triangle if we have the 2 other sides, and the only triangle which has 2 sides is this one here. Now if I put an X beside this side, that's the hypotenuse. You can see it's opposite the 90-degree angle. So Pythagoras tells us that x squared equals 1 squared plus 1 squared. Now 1 squared is 1 plus 1, and that equals 2. I'm going to do something similar to what I did in the example 1. I will of course take the square root, but I can leave the square root like that because I'm going to use it. I could of course write it as a decimal, but I'll not do that just now. So we've just worked out that this side here is the square root of 2. Now I want to look at this triangle. You can see that we've got one side and we've got this side here. That should allow us to work out this side. Let me just call that A. A is opposite the 90-degree angle. You can see that, I hope. So it's a longest side calculation again. Here we go. A squared equals 1 squared plus the root of 2 all squared. 1 squared is 1. If we square the square root of 2, we just get 2. So that gives me 3. And I can work out the square root of that, or take the square root. But I'm going to do what I've done before. I'm going to leave that as the square root of 3. Now I could write that again as a decimal, but I'm not going to bother. So that takes us to the last triangle. And the last triangle is this one here. Now we've just calculated that this side here is root 3. The side that we're trying to calculate is the hypotenuse because it's opposite the 90-degree angle. The longest side calculation again, this is the last one. So c squared equals 1 squared, this one here, plus root 3 all squared. 1 squared is 1, root 3 squared is 3. So, and that gives us 4 as the total. C squared equals 4, and C then equals the square root of 4, and 4 is a square number, so I can give the square root as 2 exactly.